right, so I'm going to show you how to make a histogram by hand. So when I say sketch a histogram, that this is more or less what I'm looking for, right? So I have measurements written on these little squares of paper for the height of students from a class in statistics taken of actual students from a couple years ago. And so they're converted from inches and into centimeters, right? So I've got these heights in centimeters and I want to make a histogram of them so I can see the distribution. And I've already looked through them, so I know which are the highest and lowest values. So these are heights in centimeters, and I know they're going to be between 140 and 200. So to mark off your axis, you want to make sure you have a width that's total width that's going to include your highest and lowest observations. And then you're going to mark the tick marks in between just so that they're even. They have to be the same distance apart from one another. So I've chosen this increment of 10 centimeters here. All right. And frequency, or how many times you observe a measurement that's in this interval, is going on your y-axis. Depending on the kind of data you have, it could just be a count, or it could be a relative frequency. So you could have calculated it as a percentage or a decimal fraction. We're just going to do counts. All right, so the first thing you need to do to make your histogram is to sort your observations into numerical order. So I'm just going to start by putting the larger ones towards the bottom, the smaller ones towards the top. Another one 75, 68, 71, 72, 8, 60, 57, that guy in there. All right, so for each of my sections along the x-axis, I can also write that as a little table. And this is how it's going to look when Excel is doing the analysis for you. So I've actually got between my 140 and my 150, I don't have any observations. And so that count is going to be a 0. Between 150 and 159, I've got 3. Between 160 and 169, I have 7. Between 170 and 179, I have also 7. And then between 180 and 189, I have 3. And I don't have any higher than that. All right, so sketching by hand, it's okay to have, one extra bin on each end. And Excel won't give you any extra bins on either end either. So now I'm going to take and slide into their slots on the x-axis my observations. So within each of these x-axis intervals, I'm just going to stack the observations on top of one another. And I've cut these little papers on purpose so that they're square. And the tick marks on the x are the same width as the tick marks on the y-axis. All right, so the reason I'm aligning these and laying them down here is to help you understand why each of these observations, sort of like the space that it takes up on the graph. All right, so we want to have them snuggled together because they represent a continuous variable, right? So they don't have to be perfect. Sorry. They don't have to be in order once we start to stack them, because what we're trying to do is just show how many observations go into each bin. All right, okay, so I counted them up. I could make my graph just looking at these tallies, right? So to sketch your graph, we now can see that these bins at the edges each have 3, and the bins in the middle both have 7. All right, so if I were just sketching my histogram, I really wouldn't need to make all these little papers. I would just need to look at these tallies. So for 150 to 159, this bar first. And I'm going up to 3. And my next bar is going to go up to 7, so I can draw that while I am at it. I'm using my straight edge here just to make sure it looks perfect. But when you're sketching on your paper, you don't have to make it just perfect. I know if your personality likes perfect lines, mine are not going to be perfect. They're going to be okay. Oops, that one, what did I do? 50 to 59, 60 to 69, that's 7. One next to it is also going to be 7. Oops. And then from 180 to 189, I'm going to have 3. All right, so here is my sketched histogram. So this is unimodal, it's symmetrical. There's not that many data points here, so it's not going to be a super perfect normal distribution. But one thing I want to have you notice is that there's no observations that are outliers here. It's perfectly likely that we would get somebody who was unusually short or unusually tall, because these heights exist in the human species, in our populations. All right, so suppose we got an observation that was over 200. It wouldn't look that unusual to have one observation over here, but suppose it was way over here. Suppose we had over 300 centimeters, right? So that observation would definitely be an outlier. Now, what you do with outliers is going to depend on what you find out about them, right? So my first question to ask myself if I see an outlier in my data set is, uh-oh, what mistake did I make? All right, so maybe this unusually high number is somebody who made a mistake in calculating their height in centimeters. They just made a mathematical mistake, they reported it. So when we do quality assurance or quality control, we look back through all of our data and figure out if any of the data points are a mistake of some kind. They just don't actually represent that there is an individual of that unusual measurement in your population. Sometimes you've just written or typed something wrong. I suppose somebody could, give me their height and it was, they just made up a weird number that would look strange on the graph. But normally in your data sets, the outliers are either a mistake that some kind of quality control will fix, or they're actually a meaningful piece of data, right? So suppose we did have somebody that was very tall in the class. I mean, people come in sizes up to, 7.5 feet. So that would be a real observation. That would be something. We don't want to just throw it out of our data set because it's an actual true measurement. All right. So we wouldn't want to remove it from our data set. Now, when we would want to remove it from our data set is if we have no accountability for that piece of information and we maybe highly suspect that there's been a mistake, or that it's just such an unusual reading that we want to remove it. So the analysis is more focused on typical readings, but you weren't necessarily going to throw an outlier out. You want to make sure it's correct. And then does it actually represent something real in your data? You definitely want to learn more about that individual if that's the case. All right. That is how a histogram is made.